Today's topic's the ideal gas law. And it sounds a little crude, okay, but the way to remember the ideal gas law is perv-nert. Alright, so it's PV equals nRT. P is pressure, V is volume, N is number of moles, R is this, it's called the universal gas constant, so it's got several values as you can see here. Alright, so universal gas constant, first one is liter atmosphere per mole degree or per mole Kelvin, and the next one is kilopascal times liter divided by mole Kelvin, and then finally we have the value in millimeter of mercury. And really, guys, you don't have to memorize those numbers. They will be provided for you. And you notice all those units in there. Those units are going to cancel out. So basically, excuse me, we take the equation PV equals nRT, and then we can just rearrange it. So if we're looking for a pressure, and the problem will identify that. It will say, like, okay, what is the pressure when? And so if you're doing that, you just rearrange the equation. And so for pressure, it's going to be nRT over V. If you were looking for volume, it's going to be nRT over P, like that. And if you're looking for number of moles, you just rearrange it, and it'll give you PV over RT. You could actually derive the universal gas constant this way as well. But typically, I don't ask you to derive it. We could do that. Anyway, it's going to be PV over NR if you're looking for temperature. And always temperature is in Kelvin. So if you see degrees C, whether it's on the front end of the problem or the back end of the problem, you have to go over to Kelvin. Now, the other thing you need to know, or I'm going to show you how to do it. You're not responsible for deriving these equations, but using the ideal gas law, you can derive molar mass, and density. And there's a little mathematical trick I'm going to pull to make this work. And pretty much what I'm going to do is say that molar mass, big M, is equal to mass over number of moles N. Alright, so remember, molar mass is going to be grams per mole. That's the unit. Alright, so grams per mole. And if we use this little, I'll say, mathematical trick, we can rearrange this thing, and it's going to tell us that number of moles equals to big M molar mass. Oh, sorry, I got that a little bit backwards here. It's going to equal to little m, so mass over big M molar mass. Now, that's the trick we use to derive all these equations. So if we can rearrange our ideal gas law to say number of moles is equal to PV over RT, and we know that the number of moles is also equal to little m over big M, then we can just sort of change that equation and rearrange it around to say that mass, little m, is equal to molar mass, big M, times PV, and that's over RT. So that's one of our, I'll say, sort of key equations. But the more useful one is if we rearrange this one to say that molar mass, big M, is equal to mRT over PV. And the reason why I say this one, because if you can see, you got, let me change colors here on you. Mass, you got mass there, you have molar mass there, and if you look really, really carefully in the middle here, you see M over V, and we know that density, oops, not very good, density equals mass over volume. So we can do a further derivation where we say molar mass is d RT over P. And so now if we further rearrange that, we get a formula for density equals MP over RT. And what does all this stuff mean? Well, it means that you have formulas now for density. You've got formulas for, well, I'll say the better one is molar mass. And you can also find a mass. Okay, so my advice is memorize one of these equations, and then you can just rearrange them to get them all. And the equation I think that I would most be apt to memorize if I were you guys is this. Now you can do the derivation, but you're not really responsible for that. All right, so let's get on to some calculations. Now you can see that it's immediately that it's an ideal gas law equation. Why? Because when you look at it, you notice that you have volume. Oops, you have temperature. Now it happens to be in degrees C. We'll fix that. You have this, and notice up here it says how many moles. How many moles? So what you do, first you start out with your equation for the ideal gas law, and you say, all right, it's going to be this Pevner thing. So PV equals nRT, and then it's looking for number of moles. So you got to rearrange it. So basically, N equals, it's going to be PV over RT. And then now it's just sort of plug stuff in and remember that you need to be in Kelvin. The other thing you have to do is you have to look at your millimeters of mercury, in other words, pressure, and then you choose the R value that is in millimeters of mercury. And that value for R is the one that's the 62.4. And then if you notice the units, it's liters times millimeters mercury over, and that's mole times Kelvin. All right, so now it's just a matter of plugging it in and making it work. So let's just go to that part. We have, I hope it fits even. Pressure is 780, and that's 0.0 millimeters mercury. Then we have, let's see, volume is 990.0 milliliters, but guys, I don't know if you noticed that over in here you've got units of liters, so you want to convert that. So I'm going to go 9.990, and that's going to be liters. Okay, so we've got P, we've got V, now we've got to put in R. There's our value up there, 62.4 millimeters mercury times liters, and then that is going to be per mole and times Kelvin. Now you notice how I flipped. That's a denominator of a denominator, so I flipped that up into the numerator to make that work. And then finally we have to have T, but T has got to be in Kelvin. Kelvin is going to be 304 Kelvin. Alright, so we've got all our little numbers in there. Now we're going to go and we're going to cancel our units. So millimeters of mercury go away, liters go away, Kelvin goes away, and you end up with an answer in the unit of mole. So, and you'd expect that, of course, you're looking for how many moles ultimately. And I'll go back and look, I see 4 sig figs, 3 sig figs with the original temperature. There's 4 over there with the pressure, so my answer has to be in 3 sig figs. I go to my calculator, I punch it in. Don't forget to use your parenthesis in the denominator here. And basically what we get is 0.0407, and then the unit is going to be moles. Alright, so there is your final answer. It asks how many moles, and bam, you've got it. Now, next one we're going to do is a little bit different, where we have to calculate the molar mass, big M, of a gas. It's got grams in it, it's got liters in it, it's got degrees C, which we have to go over to Kelvin, and it gives us atmospheres. So if we're looking for big M molar mass, if you remember the equations that I had talked to you about, I kind of said, well, it might be good to go little m, like that, equals m, oh wait, sorry, I kind of messed that up. Let me go back. Actually, the one I recommend you memorize, I suppose, would be the one with big M. So big M equals MRT over PV. So MRT over PV. That's probably the best one. Obviously, it works well for this particular application. We can rearrange it to get little m. We can do a density calculation off of this one. So this is the most versatile, I would say. Anyway, but there it is. Those are all your values. And if you notice, when you go back up and look, we have a mass, so that's going to be little m. We've got a volume, we've got a pressure in atmospheres, and we got a temperature in degrees C. I'm going to take that temperature right now, convert it to Kelvin. So if I go to my calculator, or if I just write down what I already got, and it's 313.5 Kelvin, and I'm noticing that atmosphere number. The atmosphere number is going to govern which R I choose. Okay, so my R that has atmospheres in it is 0.0821, and that's liter atmosphere per mole Kelvin. Okay, so that's pretty much all the stuff. Now let's just plug the information in and make it work. So the mass we got equals is 42.50 grams. We have an R value of 0.0821 liter atmosphere. And then, here, guys, it's mole times Kelvin in the denominator, so that looks a little better than that last one. Then finally, we have to have a temperature. We said that was 313.5 Kelvin. And then, let's see, the next thing we got to do is put pressure in. Pressure is 65 atmospheres, 0.08 m. And then, as we're going, we got to get a volume. The volume is 8.70 liters. All right, so let's go back and we'll cancel our units. All right, so it's going to be liters going away. There we go. Atmospheres go away. Kelvin goes away. And look what we're left with. We're left with grams per mole. Well, that's a unit of a molar mass, is grams per mole. So now we're just going to finish the job. We punched in our calculator, careful with the parenthesis on the bottom and all that kind of stuff. And we end up with 1.93, and that's going to be grams per mole. Now that certainly sounds like a molar mass. Let's go back and check. We've got a bunch of sig figs there, 3 sig figs there, 3 sig figs there, 3 sig figs with the original temperature. So our answer is in 3 sig figs. So that's pretty much how you do a couple of these ideal gas law problems, do the derivation. And you're going to get any variation of ideal gas law problem. You just basically use this equation. Or if it's just with moles, you can use the PV equals nRT equation. Enjoy.